So my next example, I tried to find something that had similar characteristics to what we were talking about in the last video, but might be a little bit easier to see. I'm going to do this one two different ways. I'm going to do two different problems. I'm going to first do the problem where we rotate this around the x-axis, and then I'm going to also do it so that we rotate it around the y-axis. I'm going to use shells both times. Okay? And then we'll talk about, though, what would happen if how we would do it if we chose to do washers or discs. But I'm not going to go through the whole thing a second time. So starting out with the x-axis as our axis of rotation for my first part. So I'm going to go around this way. So if you remember the thing about the shell, of course, the axis is in the center. So as I take this around, I'm going to have something like this kind of shape, sort of like a top. Hey, I didn't use the food. I'm trying to think of a food that looks like this now. Okay, that's not what I need to be doing. So when I draw that cylinder, this axis is going to be going down the center of the cylinder. So my cylinder is going to be looking like this. Now that may be a little bit easier to see than the previous example. Well, I hope it is anyway, because it's not all over the board, right? This is all together. That cylinder is just right in there. And so these cylinders, the end here is going to be very long and thin, and then this one's going to be short and fat, but you've got basically this idea of all these concentric cylinders. Now, if I look at this, I can see because it's going this way, the radius is going to be here, radius here, and the height of the cylinder is going to be here. Okay. So my radius is going in the y direction. Okay, so as I'm going to start out using this radius, height, d thickness, I'm going to write it here, volume. It's 2 pi. My radius is y. And then the thickness is the same direction as the radius because we're doing the shell, so that's going to be dy. And I have to figure out what this height is. Okay? Certainly the height looks like x, right? It's in the x direction, but I've got two separate curves here, similarly to the previous example, but now they look more like actual curves, right? One is a curve and one is a line, but they both have a very clear formula. So my height is going to be the x value on the right minus the x value on the left, right? This guy minus that guy. So that's going to be the height of each cylinder at each different point y. So in this particular example, they gave us y as a function of x, so we have to change this so that our variable is x, right? So if I take, okay, my right one is here, that's the line, so this is going to be x equals y minus 2. I'm sorry, 2 minus y. Let's get it right. And so if I put that over there, that way I get 2 minus y. And then my left curve is y equals square root of x, or x equals y squared. So that's going to be the height. I do have to think about it as the difference of the two curves. So I'm going to put this in here. And then in order to integrate, I also need my limits. So didn't write it down, but it's very easy to figure out at this point is 1, 1. It's drawn that way. Definitely that's the point, right? Where these two are equal, right? No problem there. So my limits in y, because I'm integrating with respect to y, so I'm going from 0 to 1. All right, so this integral is not hard to do. Don't go too fast. I did this too. First, I want to just do this. Then I want to actually integrate it. So this is y squared minus y cubed over 3 minus y to the 4 over 4. Evaluate from 0 to 1. And I did this somewhere here. 5, 5, or 6 is the answer. All right. If I wanted to do this with washers instead, in fact, they would be discs, right? Because it's solid, with my solid top, something like this. So my disc, though, I would have to break this up into two different integrals, right? Because here I'm going up to this curve, and here I'm going up to this line, and they're different. So the difference is, if I did this with discs, it wouldn't be any more difficult. It would just be set up differently. I would have to set it up as two separate integrals. Okay. Now the next thing I'm going to do is I'm going to erase, because I want to do the same picture, but instead of going around the x-axis, I'm going to go around the y-axis so you can see the difference. So how we would set it up and everything. Let me just kind of fix it up here. So starting over again. But now I'm going this direction. So all this is the wrong thing. Clean blackboard, more or less, what we can't reuse. So if I put this around this direction, of course, you'll see a different, or you'll imagine a different solid. So of course the answer isn't going to be the same in both cases. And here if I draw my kind of, it's a more of a standard looking shell, right? It's just going to be like that. Here's my cylinder. So you can see in this case, I'll write it here, but that the radius is going to be x, the thickness is going to be in the x direction, so I'm going to have an x, and I'm going to have a thickness which is dx, and then for the height, I'm going to go up to the curve. So my height is just going to be y. And now you see, okay, now I have to do kind of what I might have had to do in the other case if I had used the other method, because between 0 and 1, when my height goes up y, I hit this curve, but between 1 and 2, say I'm looking at one of the bigger cylinders out here, like wider cylinders out here. On this cylinder, to go up, I'm going to hit this curve. So for this particular shape, if I wanted to use the cylindrical shell method, I have to break this up into two different integrals, because my height, the way my height is defined, is different on the two regions. I'm going up and I'm hitting a different curve. So the radius is still going to be x, and it's still going to be with respect to x, but I'm going to have to do between x going from 0 to 1, I'm hitting this curve, so my y is square root of x for my height, and then on the next part from x going from 1 to 2, I'm going up and I'm hitting the line, so my y is this guy. Right. And so that's the thing. it wasn't hard to split it up into two, but like you just need to know that you have to do it, or you have to recognize from the picture that this is what's required. And so as you see, on the two different pieces, I have a different function. And I also have the different limits. But remember again, because I'm integrating with respect to x, my limits are in x. And if you evaluate this, I did it somewhere. Where did I do it? Oh, here, 32 pi over 15. All right. Assuming I added it right, which one can't always assume these things. So that's that. Now again, I could have chosen, unless they specify, by the way, that's going to be the case in this class. And on WebAssign, they don't know how you did it. They just want the answer. But with respect to what I'm assigning you, if I tell you, do it this way or that way, you have to do it that way, not the other way. But a lot of the times I don't care, and I let you choose the way you want. So you can go ahead and do it whichever way you want. Just get the right answer, and we'll show your work. So you'll see on the worksheet for this week, some of them it specifies, some of them it doesn't. Sometimes it's helpful at first when they specify, so you know which way is going to work better and you don't waste your time. In this case, similarly to the previous example, like you see, if I had done this with washers, right, I'd be integrating with respect to dy. Actually, this would be very easy to do with washers. I would always just do this washers without instead of shells, because this would be your outer radius is the line and the inner radius is the curve. So this would be a nice, easy washer problem rather than splitting it up into two. But it's just a question of what you feel more comfortable with. Some people find it easier to visualize one method or the other. For me, I always have a harder time visualizing the shells, but there are some people who may find that easier to visualize in the washer. So it's really up to you in these kinds of situations where there's a choice. You just do whichever one you like the best.